Hey folks, and welcome to our new unit. This is unit number 10, and we're going to be learning about ions, chemical bonding, and naming of compounds. Today we're going to be introducing the concept of ions, and then you're going to have a practice sheet to do so that way you can be very comfortable with ions because they're going to be very important as we move into chemical bonding and naming of compounds. So, as a review, we've talked about isotopes before, and remember that isotopes are atoms of the same element with different masses. So, for example, hydrogen has 3 different isotopes, and each of those isotopes has a different mass number, right? So we have hydrogen 1, hydrogen 2, and hydrogen 3. Why is it that those hydrogens have different masses? Well, it's because the number of neutrons is different. Remember that we've said that the number of protons is the defining characteristic of a specific element. So hydrogen is always going to have 1 proton, right? And because these are neutral atoms, they're also going to have 1 electron, but the number of neutrons can be different. So let's talk about ions. Ions are atoms of the same element with different numbers of electrons. Again, because the same element always has to have the same number of protons, right? The number of electrons can differ, and that is what is going to become an ion. Because the number of electrons is different, the atom becomes charged. Remember at the beginning of Unit 8 where we did the activity with the pieces of tape, where we were charging those pieces of tape by pulling them apart from each other? What was happening is that when you were pulling the pieces of tape apart, the electrons are being pulled from one side to the other, and that was making it charged. So when an atom loses an electron, right, now the nucleus has, in this case, 3 protons. When you lose an electron, now there's only 2 electrons. You have 3 protons, 2 electrons. Protons are positive, electrons are negative. Overall, it's going to become a positive charge. Let's take a look at a couple more examples. Right? How can we figure out the charge of an ion? So ions can either be positive or negative, right? And that's because protons are positive and electrons are negative. So we calculate the charge by taking the number of protons and subtracting the number of electrons. Because protons are positive, we have to subtract the number of electrons, which are negative. So for example, in a neutral atom, we're going to have 6 protons and 6 electrons. The neutrons do not factor into this. They don't matter because they are neutral. If we have a negatively charged atom, that must mean that there are more electrons than protons. So here we have 5 protons and 6 electrons. 5 minus 6 gives you -1. So that gives you a -1 charge. If an atom is positively charged, that means that there are more protons than there are electrons, right? Because there's more positive charges. So here in this example, we have 6 protons and 5 electrons. 6 minus 5 gives you +1, all right? So that's kind of the basics. Let's take a look at some specific examples. First of all, when you write ions, we use a specific thing called ion notation. It's kind of similar to when we did the isotopes, right? But remember on the isotopes, you had the atomic mass on top and the atomic number on the bottom. Here, we just take the element symbol and we write the charge, right? So if it's neutral, you don't write anything. You would just leave it blank. If it's positive, you would write plus and then whatever the charge is. And then if it's negative, you would write a negative sign and then whatever it is. So that's ion notation. That's how you would write a specific ion. You may have to work backwards. So sometimes you're given the number of protons and electrons and you have to find the charge, right? But other times you need to be able to work backwards. So for example, with our sodium +1, right, we need to know what is the charge, or how many electrons does sodium +1 have? Well, we know that sodium, if we look at the periodic table, has 11 protons because the atomic number is 11. It's always going to have 11 protons. Now, it's a +1 charge. That means that it's going to have 1 more proton than electron. Okay, so if I have 11 protons, then if it's a +1 charge, I'm going to have 10 electrons. Another way to think about this is that a neutral atom of sodium is going to have an equal number of protons and electrons. So 11 protons and 11 electrons. If I have a +1 charge, that means I've lost 1 electron because electrons are negative. So losing a negative electron gives you a +1 charge, which means that if you lose an electron, 11 minus 1 gives you 10. So two different ways to think about that. You can either start with the number of protons, and if you know that it's plus 1, you know that you have 1 extra proton, or you can say, okay, my neutral atom has 11 electrons. If it's a plus 1 charge, that means I've lost an electron, which means I now have 10 electrons. Second example, here we have oxygen with a minus 2 charge, okay? Oxygen, we look at our periodic table, atomic number 8, meaning that it has 8 protons, okay? Let's think about our two methods here. Our neutral oxygen is going to have the same number of electrons as protons, which is going to be 8. So it's going to have 8 protons and 8 electrons. However, it's a minus 2 charge. That means we've gained 2 electrons, which means that we're now going to have 10 electrons. We also can think about this as oxygen, 8 protons, minus 2 charge, means that there are 2 more electrons than there are protons, and therefore we would have 10 electrons, which is what we see here. All right, so those are a couple examples there. And let's do a couple more examples on the whiteboard. So here is my whiteboard. All right, so let's go working forwards again. So let's say that I have an atom that has 7 protons and it has 10 electrons, okay? Well, we got to look at our periodic table. 7 protons means that it is nitrogen, all right? And now we need to look and figure out what is the charge going to be here. Well, I've got 7 protons and 10 electrons. Two ways to think about this. A neutral atom of nitrogen is going to have the same number of protons as electrons, which would be how much? 7, right? So 7 electrons would be the normal number. So if it's neutral, it would be 7 electrons. Well, how many more electrons did we get here? 3. What charge do electrons have? Negative, right? So -3 would be the charge. The other way to do this, right, is to take our number of protons and subtract the number of electrons. So 7 minus 10 gives you -3. And so that would be how we would work to get to that one. All right, let's do another example, but this time let's work backwards. So if I have a lithium with +1, okay, lithium +1, how many electrons does lithium +1 have? Well, lithium has 3 protons, atomic number of 3. So a neutral atom of lithium is going to be having 3 electrons, right? If it was neutral. But this is not neutral, it's a +1 charge. If it's +1, that means that there's 1 more proton than there is electron, which means that we are going to be having 2 electrons. Okay? So use this information to work on the practice, and I'll see you all next time.